I'm into energy materials. Basically, it's photocatalysis that we do on metal oxides.
I work on atmospheric chemistry, mainly air pollution and air quality.
I'm in organic chemistry, and I work on biological system and metal ions.
Molecules that are conjugated, that is, they have a pathway along which electrons can move.
My research field is about smart nanomaterials to be investigated at the interface with the bio-related objects.
I work in fabricating silicon nanostructures and innovative processing for application in solar cells and in microelectronics.
You're putting together a lot of disciplines from different fields.
It's my first time here to attend this conference. It's very nice.
Friendly environment was a new experience, but very interesting.
So this is my privilege to welcome all of you in the 27th Assembly of Advanced Materials. And this is going to be, of course, as usual, interactive, because the format of this conference is how to build more interactive sessions, and that's why we put all in a single vessel. So we will sail today all the way on Baltic Sea and will visit Helsinki tomorrow, and then in the evening we will sail again and back to Stockholm.
The realization by nano-imprint lithography, and you have the blue curve, which is the reflective spectra of the inverted cone grating.
We directly produce hydrogen by coupling, say, a solar cell or solar panel to an electrolyzer with a DC-DC converter. Or there's an this is an indirect way, and there's a direct way where you can produce this by immersing a system of photoabsorbers, a photoelectrochemical cell, directly into the solution and produce hydrogen in a direct way by photocatalysis.
Let's talk about cost, okay? On the left here, NASA and European Space Agency for a long time have flown sounding rockets. Black Brant in Texas, for example. This is launched north of here in Sweden. And that's about $2.5 million US or more.
With plasma polymer for appropriate surface properties, then attached to the surface of this microparticle nanoparticles to create nanotopography with tailored outermost surface chemistry implanted in mice in order to look at in the peritoneal cavity of mice in order to look at the inflammatory responses. And we have, for example, what we did.
Then from the scan data, a 3D model is created on computer using a specialized software such as computer-aided design. And this 3D model is converted into machine language to manufacture the scaffold using, for instance, resorbable polymer.
We have quite an extensive laboratory where we test a number of things in the lab, but then we also do a number of field tests. We focus on innovative and emerging technologies So basically the reason we do that is we're trying to advance the way that we design, build, and maintain infrastructure.
And there are automated processes, but also manual processes for the production of FRP parts. And I want to highlight this hand layup process, which is the manual one, and according to our partners, still the most applied method for FRP component production.
That's something completely new and something really funny and very nice, I must say. Going from one country to the other and not even noticing when you cross the border and waking up the next day in a completely different country.
It's really nice, it's different, and it's very well organized.
You put people all together, and so it's easier to have to speak with each other. It's not, there is no dispersion, and I never. This is the first time on the boat. Actually, it's fine.
It is something really new to me. I find it very innovative from some point of view. It has some advantages like you reduce the time to reach the hotel, so this is very useful from this point of view. And also it helps a bit more the networking.
It's more convenient because you are closer to the conference room. Yes, it's practical from this side of point of view.
Normally when we start projects, there's a few ways that we will often start projects. So we might see a problem and we might come forward, the research team might come forward and say to an airport authority or to a road authority, you have a problem here.
The most important mission was for me to increase the output signal more along the product's roadmap.
My impression is that the role of the university or university education is to get people trained in a lot of basic knowledge, which may be very useful for industry later, to really develop also methods and knowledge that at some point may be useful even for technological processes.
I would like to share with you today my experience as a coordinator of a European project in the framework of a Meronet call, which is a specific project that needs both academia and industries. And actually the reason to search for this project was looking for funding, but at the end it resulted what we got success in this application.
Cultural heritage.
It's been a very interesting conference to me because most of the speakers were about fields that I know nothing about.
I found it very interesting. I followed very enlightening and interesting talks. I've learned a lot so far.
You're putting here together a lot of disciplines from different fields, and it's very, very interesting to see also something aside the specific stuff that you do yourself, and you see some other fields come in and how they relate to what you do. It's very interesting.
It's a very nice experience to attend this conference, very new concept, so yes, why not? It's really nice.
So I will recommend this type of conference because it's a conference also in a ship. It's nice, and it's also with many thematic, and so it's multidisciplinary. So everyone can find interesting topic for his own research, of course.
Yeah, I think it's an experience to try. Yeah, I think it's a positive experience. People can enjoy it.
Try. It is an experience. It's something was totally new for me. I was expecting something new to test. It's definitely worth to try, and you will enjoy.
I would recommend to go, definitely. Yeah, it's great. It's great fun, and it's good science.